Hey guys, welcome back. In this lesson, we're gonna cover application of non-standard normal distribution. To solve those type of application of non-standard normal distribution, usually what we're gonna do is some sort of data set we're given. It would say that the data set is normal distributed, and to find the probabilities for a corresponding values of the x. That's what we're given, and then we're gonna convert that to the z-score, the corresponding z-score, and then use the z-score table to look up the area, and then that should correspond to that same area from the given distributions. So in terms of picture, this is what exactly happening in this problem. We said we're going to be given a normal distribution, and then the variable is going to be in x, in continuous random variable x. Okay, so that's what we're given there. So to draw that, we're gonna draw a normal distribution. Okay, and then this could be an x variable. Let's say we have the mean here, and then whatever the sigma may be. But we know it's not going to be 1. The mu can't be equal to 0 because standard normal distribution will have the mean of 0, standard deviation of 1. So we know that that's not the case in this case. So and we asked to find the probability of certain event that is less than a particular value x. Call that A. Let's say here's A. Okay, so this means we want to find this area to the left of A. That's what this is. Okay, so our goal is to convert this A here to a z-score. Okay, to a z-score. Let me go ahead and erase this here to a z-score. And to a z-score using this formula, z equal to x minus mu over sigma. Okay, and when we do that, that x value will correspond to a particular number of standard deviation above the mean. In the new graph here, this is the standard normal distribution. So that's going to be in the z-score of mean equals 0 and sigma equal to 1. So the horizontal axis is going to be in z-score. So this value A here for this x distribution is going to correspond to a particular z-score or a certain number of standard deviation above the mean. So that z-score there will be used, will be this new value if we take A minus mu over sigma, whatever A is, plugged onto this formula. And that will give us that z-score. And that z-score will yield an area to the left that exactly the same or approximately the same as this area over here from, the two graphs there. So same area or same probability. Okay, so that's the goal, is start with the non-normal distribution, convert the particular value to a z-score, use a z-score table to look up that area, and we learn how to use a z-score table in 6.1. So let's go ahead and solve some problems here. In this first example, I'm going to show you guys how to do this using the long way. The long way is what I just demonstrated in this picture, is take a particular value of x, convert that to value z, look up the area to the left of that z-score using the table, and then that should match up the area that we're asking for. Okay, so in this question, example 1 here, we're given a distribution of IQ scores that is normally distributed. So this means the IQ scores has a normal distribution with a mean of 100 and standard deviation 16. Okay, and we asked to determine the percentage of people who have IQ score between 115 and 114. So suppose we want to call this IQ score variable is x. Okay, and we want to find out what percentage of people, what is the probability of people or a random adult has an IQ score greater than 115 and less than 140. Okay, so to do that, we're going to convert each of this score to a z sub 1 and a z sub 2 using this formula, z equal to x minus mu over sigma. So in terms of picture, this is what it looked like. Okay, we start with the IQ score distribution. Here's 100 in the middle, 115 is there, 140 is there. We want to find that percentage or that area. It's the same thing. I look at a standard normal distribution with certain z-score. We don't know what they are because we have to convert it. And then that is the same area there. So call this z1, call this z2. Okay, so let's do it. Let's find those two z-score. Okay, so z-score 1 is going to be 115 minus the mean is 100 over the standard deviation is 16. And if you do that correctly, it should turn out to be 0.9374, round that up to 0.94. And then z-score number 2 is going to be 140 minus 100 over 16 equals, that will turn out to be 2.5. Okay, and now to find that area right there between these two z-score, okay, we're going to use the z-score table to look up the area. So we're looking at the area to the left of z-score number 2, which is p of z less than 2.5. And then we subtract that to the area to the left of the lower z-score, which is 0.94. Okay, so if you do this correctly, the answer should be 0.1674. And I'm going to show you guys how to get each of those area. So let's look at the area to the left of 2.5 z-score. So 2.5 z-score is going to be down here on the positive. So 2.5 z-score will have area 0.9938. So 0.9938, 0.9938, subtract the area to the left of the z-score of 0.94. So 0.94 is there. So we're looking at that area to the left, 0.8264. 0.8264. And if we subtract that, we should get roughly around 17%. So to answer this question, we say that the percentage of people who have IQ score between 115 and 140 is around 17%. So that means there's about 17% chance if we ask a random adult on the streets, hey, what's the chance to find out that their chance of having a high IQ score between 115 and 140 is about 17%. So that's another way of interpreting it, okay? All right, so let's moving on to the next example here. I only have 2 minutes in this video. I'll try to make this short here. I'll draw a picture instead to start out what the question is asking. So this is saying that what is the IQ score that correspond to, what is that IQ score, call that A, that correspond to the 90 percentile. So to this 90 percentile is the same thing as area to the left of an IQ score. Okay, so we're asking for what IQ score corresponds to 90 percentile. And that's what we learned last couple chapters ago. So it turns out that if we look at the standard normal distribution, this IQ score A here will be this same number distribution away from the mean. Okay, whatever that is, but it will be at the 90 percentile, meaning it's gonna have a 0.90% to the left of that, whatever that z-score, call that z-star. Okay, so in the next video, I'm gonna show you guys how to find that z-score there that correspond to 90 percentile. So we said find a z-score corresponds to the 90 percentile. Okay. All right, I'm going to end this video here and I'll show you guys how to do that in the next video.